This is the third in a series of videos on graphing polynomials by hand, and this deals with the step number 2. So here are the steps to graphing polynomials by hand, and we're focused on this part, determine the end behavior. And the way that you determine the end behavior is you use what's called the leading term test, or some books call it the leading coefficient test. And leading term test. And though we're going to go over it briefly here, this has gone over in more detail in another video. And if you look at the YouTube playlist, MA class notes, math analysis class notes, this is in polynomials part 2. So briefly, the leading term test, what you need to do is you need to determine the leading term. And let's call the leading term A sub n x raised to the power of n. So in this case, a to the n is the leading coefficient, and n will be the degree of the polynomial. And it turns out that all you need to determine is whether or not the leading coefficient is positive or negative. So if an is positive or an is negative. And then you need to determine whether the degree is even or the degree is odd. Remember, n is degree, and this is the leading coefficient, a to the n. So what do we mean by end behavior? End behavior talks about what happens to the polynomial when you get far away from the origin. So for example, no matter if you have a polynomial, it can be quite complicated in the center of the distribution, but the ends it's really clear. If an is positive and n is even, then it's like x squared. And that's the way a lot of people learn it. It's like x squared, so that the end behavior will look like this and like this, even though you don't know what it looks like in the middle. The reason I drew this dotted line is I don't really know. But that's the end behavior when the leading coefficient's positive and the degree is even. Now if the degree is even, but the leading term is negative, then you simply have x squared flipped. So this is like negative x squared. So that looks like that, and like that. And again, you don't really know what it looks like from there. And that's the end behavior there. If the leading term is positive, but the degree is odd, then it looks like x cubed. So it looks like this. And this goes up, and this goes down. And you don't know really what happens in the middle. What happens if n is odd, but an is negative? Then it's like negative x cubed. So this goes down this way, and this goes down this way, and again, who knows what happens here, at least for now. So this is something that you'll need to memorize, and I believe you have in your notes already. And again, if you need more help with this, simply rewatch this video, MA Class 9 Notes, Polynomial Part 2. And now let's do an example. Let's do g of x is equal to minus 5x to the 4th plus 3x squared plus 7x minus 9. The leading coefficient is negative 5, so a to the n is equal to negative 5, and n is equal to 4, right? We look at the term with the highest power. And if we want to look at what the end behavior there is, then it's even, so it's like x squared, but it's a negative x squared. So it looks like that and like that. Let's do another example. Let's do h of x is equal to negative 2 x plus 3 squared x minus 4 Here what you need to do is you need to find the leading term. You need to multiply this out. You don't have to multiply the whole thing out. You just have to look at the highest powers. This will be an x, this will be an x, but it'll be an x squared. This will be a minus 2. So the leading term here is minus 2x to the third. N is odd, so it looks like x cubed, and a to the n is negative, because it's a minus 2. So this is going to be like x cubed. But it's going to be like a negative x cubed. Why a negative x cubed? Because it's a negative 2. X cubed would go up here and down here, so a negative x cubed would go down there and up there. And again, we don't know what will happen in the middle.